what you see here is actually a Venn diagram, okay? And it's something that you guys probably did back in algebra, but we'll look at it here. And it just talks about the relationship between all the different kinds of numbers. And we're going to spend some time today talking about rational numbers. So we're going to pay close attention to that. But we're going to look, and we're actually going to add one set of numbers to this. We're going to add the complex number system, okay? So we'll add that as well. But what I have already set for you are all the real numbers, okay? Complex imaginary, the ones with the eyes in them that we talked about a few units ago, are they real? Do they show up on a graph? No. So they're actually complex. So they're going to kind of be their own little circle way out here. They're not part of the real. So we would say that complex numbers are kind of their own set of numbers. Imaginary numbers fall into there, that kind of thing. Anything with an I, they're not real numbers. But there are several different types of real numbers. So we're going to kind of fill in this chart here using the terms that we have up here. The two big main categories are either going to be irrational, or what's the other one going to be? Rational. And we really want to think about the difference between the two different groups. They're very distinct. You can't be both. It's one or the other. Can anyone think of an example of a number that we deal with quite frequently that's an irrational number? 3 is not irrational. 3 is actually a natural number. It's also an integer, it's also a whole number, and it's also a rational number. So 3 is definitely not irrational. -3 is an integer, not an irrational number. So let's define what an irrational is. Let's make sure we understand it. An irrational number would be a decimal that goes on forever and ever and ever and ever and ever and ever and ever and never stops. No repeats. So knowing that as our definition, pi. Pi would be an example of an irrational number that you know. There are an infinite number of placements or decimal place. It goes on forever. It never stops. E is another number. Actually, E is on your calculator. We haven't talked much about it yet. We will in future months. But E is actually above the divide sign on your calculator. So if you go ahead and hit enter and do second divide on your calculator, you will see that it also looks like it kind of has a pattern there, 2828 kind of at the end, but it goes on forever, okay? Try the square root of 6. Type that into your calculator, the square root of 6. What do you think about that one? Does that go on forever with no pattern? It should, okay? So often radicals will be an irrational number, pi. Rationals can be a decimal that stops, like 2.3, or if it repeats. So for example, 0.6, we'll say 2/3. Okay? Go ahead and type in 2/3 into your calculator. 2 divided by 3. What do you get when you type that in? 0.6666, and it says 7 at the last number, but that's because it rounds up, that's all. But it is just 0.6 repeating forever. So a rational number, and we're going to spend a lot of time today talking about what rational exponents actually, but it's a rational number often can be written as a fraction, okay? And that fraction, if you were going to convert it to a decimal, would either terminate, like if you did 1 divided by 4, 1/4. What's that going to be as a decimal? 0.25. It's a terminating decimal. It stops. So it's either going to be a terminating decimal or a decimal that repeats in a pattern. But you can write them as fractions. The next, so we've done irrational, we've done rational, we've done complex. So we've got this last set of 3 numbers here. Give me the next largest group among what's left. Integers is actually the largest group of what's left. Integers are going to be whole numbers and their opposites. So what that means is -3, -7, 2, 427, -26. Any negative number, positive number, and 0 are going to be considered an integer. So let's just pick one. I don't know, -5. Okay? That would be an example of an integer. So we know what integers are now. What's the next biggest group? Actually, natural is the smallest, believe it or not. So it's going to go whole numbers, and then it's going to go natural numbers. There is only one number different between the two. You missed a quiz, Cameron. What's the only number that's a whole number that's not a natural number? It's 0. Good. Whole numbers start at 0. 0, 1, 2, 3, 4, 5, 6, 7. And natural numbers start at 1. 1, 2, 3, 4, 5, 6, 7. Okay? Good. But today, so this is going to be something that you're going to have to recreate, okay, being able to organize all of the different types of numbers, give me some examples of those numbers. Can you give me an example of a complex number just so we have that there? 2i is an imaginary number, but it can be considered in that group. Let's do 3 plus 2i, just so we have a truly complex number. A complex has a real part and an imaginary part together. So something with i's in it, I agree. So again, we're going to recreate that for a homework pass in the near future. Okay? But let's focus on just rational numbers for a minute. Okay? And we're going to look at some ideas of what we call rational exponents. Okay? Means that the exponent is going to be written as a fraction. And if we look at this example, 64 to the 1/2 power, we have to decide how is it going to be written in radical form, because they can be. When you have exponents that are written as fractions, we can change them to radical form. It's written here right now as what we call exponential form or exponent form, and we can write it as a radical. Now, this hint that's written here is kind of the hint you need. Okay? When you have something raised to 1 over a power, it's just that's the index. So the denominator is going to be the index of what you see. So what's the denominator of my exponent? 2, which means we're going to have a square root. Okay? So again, I'm going to write that a little bit bigger. So if I have 64 to the 1/2 power, this number right here tells me that's the index of my radical. So you can write a 2 here, much like there was a 2 written there on your quiz, right? You don't have to have it written there. It's assumed to be a 2 without it. And then what the base is going to go underneath, and it's going to be raised to this power. Now I can write a 1. Do I have to write a 1? No, but I could. So the key here is the indexes and the bases are the same, and then the powers are the same. You going home? Okay. Do you have can I see your checkout pass, babe? Can I see your checkout pass? So which one of those is that? First, second, or third? First, second, or third? It's the first one. Would you agree? That's the same thing as the square root of 64. Good. Which is just what, by the way? 8. So 64 to the 1/2 power is the same thing as the square root of 64. Okay. Let's take this idea a little bit further. Okay. And this is going to be the notes if you wanted to write this formula down. Honestly, the example we just did worked too. Again, the denominator of my exponent is the index. If you have 2 numbers, notice what happens. The denominator is my index. Look where the m is. The m is the power of what you're taking the square root of. Do you see that? So let's look at column A and column B. We have to match them up. Which one goes with what? If I have 1/3 power, what does that mean as my index? 3. So which one in column A has an index of 3? The first one. Notice what happens to the 4. Is it being raised to the 1/3 power? So isn't it outside of the radical? The only thing that's being raised to the 1/3 power in that case is the x. So that's the only thing that's underneath the radical. Now, does it make sense that this one goes in this direction? The denominator of the 3/4 is going to be a 4. So is the index here a 4? And then we're raising it to the 3rd power. So that would be in this case. They just happen to match up horizontally there. Okay? So what we're going to do is we're going to convert between exponential and radical form. We're going to go in between, okay? So in order to do that, let's start with this first one. It's kind of written in a strange way, but let's start with w to the negative 5/8. And right now, how is it written? Which form is it written in? Exponent form or radical form? Exponent. Okay, we don't have any radicals yet. We're going to convert it to radical form here in just a second. So what we need to do is we need to decide, and it's asking you to identify the different parts. That's fine if you would like. The base is going to be, in this case, the A is going to be a W. I prefer not to, I think that's a little too much. Is that okay to break it down so much? I think that's too much, but let's go ahead. So if I wanted to write this in radical form, the first thing I'm going to ask you is, what's the index? 8. I agree. What letter, or what's the base, what goes underneath the radical? A W. What power is it being raised to? Not just positive 5, but a negative 5. Okay? Any questions? Wait, where did I lose you, Erin? This is a W. Negative 5/8. Sorry, it's written small. I'm sorry. So in this case, I'm not done. Chris, why am I not done? Why can't I leave it like this? What's the problem? I don't have a radical and a denominator like I did earlier. What do I have, though? Do you know? Not sure? Alexis, do you know? Not sure? Who knows? What's wrong with this problem? The negative is where? Can you have negative exponents? We really want to write our answer with positive exponents. So how could I rewrite this? Where am I going to put positive w to the 5th? In the denominator. And then what would go on the top? A 1. So that would be in completely simplified form. Okay? Any questions about that? Let's look at the second one real quick. W to the 0.2 power. Now that's not a fraction, is it? 0.2? Do you know how to convert that to a fraction? Because we need to. How do I convert 0.2 to a fraction? Well, it's 2/10. Would you agree? And is 2/10 reduced? Is that a reduced fraction? How do I reduce it? 1/5. And just check it on your calculator if you wanted to. 1 divided by 5, is that 0.2 on your calculator? It should be, right? So isn't this the same thing as w to the 1/5 power? Do you agree? So how do I convert this to radical form? If I want to put it in radical form, what would I do? What's the index of my radical? A 5. And where does the w go? Underneath the radical. And where does the 1 go? I could have raised it to the 1 power. I don't have to, but that would be the final answer there. Okay? So far? Not too bad. Okay. So, this, oh goodness, we're going to skip that. Let's look at, let's look at this problem here. Okay, so we're going to kind of combine some radicals, and it wants us to put it in simplest form. What's wrong right now with trying to multiply those two things together? On your quiz, I think there might have been one where you couldn't multiply. I'm not sure if that's true, or couldn't have added or something like that. The indexes are different. And remember when we talked about multiplying radicals, in order to multiply them, the indexes and what was underneath had to be the same. Do you remember that? Well, that's not true. The indexes had to be the same then. What was underneath could be different. So if these indexes are different, I can't multiply them the way they are, but I still can multiply them because I'm going to convert them to exponential form first. and then I'm going to show you what to do. So here's what I mean. The square root of 3, that's 3 to the what power? 1/2. Remember that? It's a fraction. So the denominator, the index is 2, it's 3 to the first power. So 3 to the 1/2 is the square root of 3. What's the fourth root of 3? 3 to the what power? 1/4. Very good. Any questions about where I got those fractions from? Now, if I'm trying to multiply, which is what the parentheses are telling me to do, multiply these, can I do that? Yeah. What do I do with the exponents? Add them. Remember, if we have x squared times x to the third, isn't that just x to the fifth? Right? Don't we, if we have the bases to be the same, don't we just add the exponents? So I'm going to do the same thing here. The bases are both 3. I'm just going to add the exponents. What's 1/2 plus 1/4? Do you remember how to add fractions? Common denominator. So over here, 1/2 plus 1/4. We could convert them both to a common denominator of 4. 2/4 plus, wouldn't that be 3/4? For those of us that are fractionally challenged, okay, your calculator helps you. Let me show you really quick how to do this if you want to check your answer, so to speak. Remember how to plug the fraction on your calculator? Where do I go? Alpha y equals, and then n/d, right? So if I say 1/2, I come out of the fraction, plus, go back to the fraction, 1/4, I'll get 3/4. So the calculator does it, okay? So I make sure you know how to do it. All right, so that's nice and all, but we want to put our answer in radical form. So how do I change this to radical form? What's the index? 4. What goes underneath the radical? 3 to the third power, because the numerator is the power I raise it to. What is 3 to the third? 27. So that is my final answer. Okay? So sometimes when you have radical functions that don't have the same index, you can still multiply them. You just want to convert it to exponential form first. Okay? Good enough? Not too bad. Okay, so let's look at this one. And I'm going to cross off method 2 because I don't want to show you more than one way to do it. I'm just going to show you one, okay? So let's look at this example. What is 32 to the negative 3/5 in simplest form? Well, first thing I notice is I have a fraction in my exponent. Don't you notice that? Okay. And that's going to pose a problem for me. Okay. What I want to look at is my base, and I want to say, which in this case is a 32. And I want to ask myself, can I rewrite that number as a power of another number? In other words, is 2 to a power that number? Is 3 to a power that number? Is 4 to a power that number? Well, if you look, I kind of got you started, and I said, well, actually, 2 to some power is 32. 2 to what power is 32? Play with it on your calculator if you need some time. 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth. Try it. Tell me which one it is. Not 16. 2 to the 16th power is a really, really big number. 2 to the 16th power is 65,536. 2 to the 5th power, though, is 32. I agree with that. So 2 to the 5th is 32. Well, hang on a minute. If I have 2 to the 5th, do you remember what I do with those exponents there? If I have x squared to the third, what did I do with those exponents? I multiplied them, didn't I? Isn't that just x to the 6th? Right? So how do I multiply 5 times negative 3/5? Put the 5 over 1 and multiply across. So I get negative 15 over 5, which is just what? Negative 3. So this crazy thing of 32 to the negative 3/5 is already reducing with no fractions. That's our goal, is to get rid of the fractions, right? So I'm doing that. But I still have a problem. What's the problem now? Negative 3, the negative exponent. So I need to write that as 1 over 2 to the positive 3. Do you agree? Oh my gosh, the email is going crazy today. What is 2 to the third? What's 2 to the third? What is 2 to the third? Say it like you mean it. 8. So the answer is 1/8. So all of that, not really that much work to be honest with you, but it started off looking pretty ugly, didn't it? And it reduced to a pretty nice clean number. Okay? So I don't want you to look at these fractional exponents and get worried. The rules still apply. When I have an exponent on the outside of my parentheses, I multiply. When I have 2 bases that are the same with exponents, I add them. They're just adding fractions and multiplying fractions. So it's kind of just the same rules. We're just doing it now with fractions, that's all. Okay? So what I'd like to do is I'd like to look at one of each type of the problem from, I thought I had it on here, maybe I don't, like your homework's going to be. Okay? So I'm going to give you, these are actually some of the odd problems in your book. And I wanted to do one of each so that you went home tonight and you knew how to do these problems. Okay? So I'm just going to write one of each of these on here. And that way it'll help you with your homework, okay? So the directions for this just says simplify. The directions for this say put in radical form. And then the last one, directions, say put in exponential form. Okay? So I'm just trying to give you one of each type so that when you go home, you're not stuck. Okay? All right. If I look at 13, and it says simplify. Again, these are the odd problems. You're going to do the evens for homework. How do I simplify that? I add, multiply, what am I putting in radical form? What am I doing? Are the bases the same? Good. When the bases are the same and I'm multiplying them, what do I do with my exponents? I add the exponents. Don't you think that might be a good place to start? So that's going to be 10 to the 1/2 plus 1/2 power. Well, what's a half plus a half? 1. What's 10 to the 1? Well, it's just 10. And that makes sense. Isn't the square root of 10 times the square root of 10? The square root of 10 squared, isn't that just 10 too? And we know that, right? Same thing. Yes, when the bases are the same, you add the exponents. All right, number 23 asked you to put it in radical form. How do I do that? What's my index of my radical going to be? Okay, 8. So I know that part. Now what? Y to the negative 9th, I agree. I don't like the negative. 1 over y to the 9th. Am I done? Come on, up top. That's awesome. Yes. Yeah. If I have 9 y's, I'm looking for groups of 8. Can't I bring one out? So I'm going to bring one out. Am I going to have one left over? So I have 1 left over, and this is wrong. What am I bringing out, actually? Am I bringing out a 1 over y? Because the y is in the denominator, isn't it? So that's what I'm actually bringing out. But that's the final answer. Isn't that pretty? I don't know about that. I might have liked it in exponential form a little better. All right, 29 says to put, this is radical form, let's put it in exponential form. All right. How do I do that? What's the index? Yeah, what's the index? 2. So what does that mean? So the 7x is all in parentheses. What is the fraction here? 3 over 2. Very good, Joyce. And I could raise the 7 to the 3/2. I mean, I could write this, but I think that this is fine. You don't have to go this far. Okay? They're both correct, but I think I would prefer you to leave your answer like this. Okay? Because it's a square root. The index is a 2. If that index is a different number, you'd put that number there. If it's not there, we assume it to be a 2. Okay? All right, so your homework is going to be just like these problems, really nothing more than that, dealing with the indices here. So it is going to be on page 386. I'm going to have you guys do problems 10 through 34 even. And pay attention to the directions, whether it's simplify, produce it in radical form or exponential form, etc. Okay? Excellent.